Hello, everybody. Welcome to my session, Java from a Parallel Universe. Some of you may know me. My name is Ouwens. I work for CodeStar, which is part of Ordina. Ordina is the company with the Duke plush items, which you will be able to win later on if you want. You may also know me from equals verifier, which is a tool that I wrote, which you can use to test your equals and hashcode methods. So before I start, let me begin by telling you something about one of my favorite books, Don Quixote, which is a book about a man who reads a lot of books. It was written in the 1600s, and in the 1600s, people thought if you read too many books, you go cuckoo. So this man went crazy, and his mind started going into some kind of parallel universe for himself. So what he did is he went out, he wanted to become a knight, a traveling knight, which was already kind of outdated by the time the book was written. And he went out to do good deeds. And he recruited a dumb peasant to be his squire, who was actually smarter than he was in some ways. And he wanted to have lots of adventures. And one of the first ones was where he went to an inn, which he thought was a big castle. And he asked the lord of the castle, who was just the innkeep, who didn't properly wash himself, to knight him, because he wasn't a knight yet. And the innkeep thought, you know, I want to get rid of this guy, so I'll just pretend like I'm knighting him with this wooden stick or something, and then he'll be out of my hair. So this happened. And then Don Quixote and his squire had lots more of these kinds of adventures where he did something crazy and it didn't always end well. One of the most famous examples of one of these adventures is fighting the windmills, or as Don Quixote thought, the giants. He saw these giants with these big swooping arms, and he thought, these giants are my enemy, I have to defeat them. So he charged at them with his lance, and of course his lance got stuck in the mill, and he fell, and it hurt a lot, and then he went on his way again. This is actually only half a page in an 800-page book, by the way. So what I want to do today is invite you into Quixote's parallel universe and think about what we are doing in a very different way. It may not always end well, but in this case, I think it will. So, how many of you have read the Pragmatic Programmer book? I see some hands. How many of you are familiar with the concept of the language of the year? So, not everybody read it very well or remembered everything. The idea is that to become a better programmer, you learn a new language, a new programming language every year. And the reason why you do this is not because you want to get a job in this programming language. It is to get a new way of thinking about languages. The idea being that if you learn a new language, you have to learn new ways about how to think about programming. And these things can actually help you get better in the languages that you are already using. So the language that I want you guys to learn this year as your language of the year, or seeing as it's already almost November, maybe you can start next year and do a full year thing. That language is Parallel Java. Now, what is Parallel Java, you might ask? Well, probably it has something to do with parallel computing and multi-threading, because, you know, parallel, you know. That's not what I mean here. What I mean is a Java from a parallel universe, a different kind of Java. Specifically, a Java without annotations. So let that sink in for a moment. So let's talk about annotations. To begin with, annotations are my windmill. I hate them, and I will try everything I can to fight them. And this is one of the ways I'm doing this, by giving you this talk. So people on YouTube, if you're watching this. So what are annotations? Well, you probably already know. They are these things. You see them in Java code all of the time. They're basically everywhere nowadays. So why were they added to the Java language? Well, C# had them, you know. That's reason enough, maybe. C# had them in 2002 when they introduced a new version, and then 2 years later, Java also got them. Same thing happened with generics, by the way, which I do think is a good addition, but maybe they should have thought a little longer about annotations. So what was the purpose? The purpose was to add metadata to your code. For example, this method is overridden, or this method is deprecated, or this thing should be non-null for some reason. So that's metadata that tools can use, for example, the compiler to check something, but that is not necessarily actionable at runtime. However, they were also added to remove external configuration, which at the time was done through XML a lot, and annotations took over that role. And I have to say, I'm happy about that. I don't like XML either. So, especially around dependency injection, this is a thing that you saw a lot. But then it also started to get used for generating code and for changing your runtime behavior in code. And how that worked was through a lot of reflection, and reflection is slow, and through code generation. So, for example, some of these annotations require that you add in some compiler plugin that hooks into the compiler and does some things. And this is all pretty magic. It's not obvious what's going on here. So I think it's actually dark magic. So why do I think so? Well, let's talk about the problem of annotations, as I see it. And the first thing to recognize is that it's not just a problem, it's several problems. For example, annotations are only checked at runtime, while Java is a statically typed language with a strong compiler. These things are only checked at runtime. And everybody knows, as one of my colleagues does, that runtime exceptions are funtime exceptions. They're always fun to analyze and to debug. Another problem is that they are weakly typed. And again, we have a strongly typed language, so this is not what we want. And how do I mean weakly typed? Well, for example, nobody, well, maybe my coworkers, but the compiler certainly won't stop me from doing this, from putting an auto-wired bean with a column and a post mapping and a test on a method. What the hell does that even mean, right? And still the compiler won't stop you from doing this. Another problem is that annotations are also stringly typed. You can add parameters in your annotations, but they can only be of a very limited set of types, like the runtime of the primitive types and strings and classes, and that's it. If you want to define your own type to use in an annotation, well, you're out of luck. So that means that you will see lots of strings like this. People who are using Spring, do you see what the problem is in this one annotation? I see 0 hands. That's disappointing. The problem is that I forgot the parentheses. How are you going to find out? Well, at runtime, maybe, if you're lucky and the method gets called. This is a kind of thing that you want a compiler to catch. Discoverability is also a problem. When I type the name of an object in my IDE and type a dot, then the IDE will start giving dozens of things that I can use to complete my statement. But if you want to use an annotation, you have to know beforehand which annotation you want to use, because if you put the cursor in front of a method, it doesn't know what to autocomplete. For all we know, it will autocomplete the keyword public or private, which is not what you want. Debuggability is also an issue. For example, I downloaded the pet store example Spring application, and I removed one annotation somewhere in the program, and this is the exception that I got at runtime when I started the program. So what's going on? Well, first thing to notice is that this is the first and the only occurrence of my own code base inside this stack trace. All the rest is Spring and Java. So it's pretty far down, the stack trace. And the worst part is this isn't even where the problem occurs. Well, it's where the problem was noticed at first, but it's not where the problem is caused. So these are all annoying things. If you want to migrate to Java 9 or above and want to do something with those cool modules that they introduced, annotations make that harder as well because they use reflection a lot. And if you use reflection incorrectly when doing modules, then you might get this warning at runtime. And ideally, you will get 0 of these warnings. You can even tell the compiler to fail if one of these warnings occurs. But as long as you're getting them, you cannot be strong in your module system, which makes it harder to migrate. So what do I propose then? I propose that you use lambdas, which were introduced in Java a few years ago, and I propose that you use just plain Java code with no fancy annotations. And all of the annotations that are in use, almost all of them, can be replaced with regular Java code, often with lambdas. So many frameworks that we use today were, of course, created before lambdas existed. They were introduced in Java 8. And annotations were already 10 years old by that time. So it makes sense that they were in heavy use. And the frameworks that are still used, even 5 years later, still rely heavily on these annotations, and they did not, deprecate all of their API and create a new one, which I understand, but it's sad still. So what if these frameworks had all dropped annotations immediately and had embraced the lambdas when they came out? Well, I'm going to show you what that looks like. In parallel Java, where you have no annotations, no magic, just plain Java. So, what does that look like for my unit tests, for example? Well, this is a test of a type that we're all familiar with. As you can see, you have a test annotation, and then you have a method name which describes what kind of test you are running. And the easiest way to get rid of the annotation here is to just go back to JUnit 3. Because then you don't have an exception, an annotation. But there is still, well, 2 problems, basically. First of all, your method now has to start with the word test, so you know there's reflection going on, so I didn't really solve the magic problem. And another thing that JUnit 3 and JUnit 4 share is their problem that you have to describe your test within the space of a Java identifier. So that means that you will be camel casing your test description. And I've seen this cause 2 kinds of problems. The first one is that people think, well, that's awkward to read, and I don't want to type something that long, so the test name becomes very short, and you don't know what it means anymore. And as a reaction to that, I've seen people actually use very long method names, which with lots of camel cases in there, and well, those aren't really very pleasant to read either. So you still don't know what's going on. If you use parallel Java, you can use a test method with a lambda and a string. This is a familiar pattern that you see in lots of other languages as well, like JavaScript and Scala, and basically all of the cool languages in use today except Java, they do this. And the nice thing about a string is that you can actually write a nice sentence that describes your test, including spaces and where you needed capitalization, which makes it a lot easier to read. Just to make a point why we didn't do this before, well, you need lambdas, and without lambdas, this looks really, really ugly and unfeasible, and you still need an annotation. So we'll just do it like this. So the pros and cons, well, I could only think of one con, and it's a really weak one because, you know, why would you do this without lambdas now that we have them anyway? Don't think that there's many people still running Java 7 in this room. At least I hope not. And the pro is that your test description becomes really, really clear. So what about web frameworks then? We are familiar with annotating our methods with an annotation like this one, where you describe what the endpoint is that the user has to call. And then when that endpoint is called, this method will be invoked somehow, magically. You still need another annotation inside the method declaration to make sure that the ID parameter is passed in correctly. In parallel Java, it would look like this. And again, this is what it looks like in all of the other languages as well. You just have a get method that you can call. You give it a string, and you give it a lambda, and that's it. And again, to make the point, without lambdas, it would look really awkward, and nobody would do this, and I would never ask somebody to do it like this. But this looks nice, right? Why don't we do that? And it gets even better because it allows you to separate your concerns of defining your endpoints on the one side, and on the other side, defining what should happen when they are called. So in this case, you can make a long list of all of your endpoints in your application and have them delegate to some method somewhere. And that way, you can have a nice looking list of all your endpoints, and you don't have to scroll through pages of code to see what endpoints are there. And you can still do your cross-cutting concerns that you would otherwise have other annotations for, like authentication. You just put it in a before block. It gets the same kind of lambda that the get annotation and the get method would get. And you can just call your authentication code there. So again, the pros and cons. Again, could only think of one real negative point about this. And the pro, again, is that your code is more readable. It has a better separation of concerns. And also a fun thing that isn't really usable in practice, but hey, still, it's there. You can generate your endpoints now because you can call this get method with an endpoint generator function and put it in a loop or something. And suddenly you have a lot of endpoints, which could be fun. Okay, databases. You're probably all familiar with JPA and with Hibernate, and that looks something like this. Again, it's annotation-tastic. There's almost more annotations in this little piece of code than there are regular pieces of Java code. And it has some other problems as well. For example, the fields of my objects cannot be final. So I cannot define immutable data classes if I use JPA, which is a big disadvantage. Also, I am forced to include a no-argument constructor because that's how JPA works. It expects the constructor to be there, and then it constructs an object, and then at runtime it will use reflection to fill in the fields. And that's unfortunate. So in parallel Java, it would look like this. You will just have a clean data class with final fields and no default constructor. That's a lot less code. So how would I use this thing then? Well, I have a query engine, and I can just pass it a piece of SQL. I'll get back to that in a moment. And when I have executed that, I can map the result of this to a bean, which is my to-do class that I showed you before. Now, I admit there's still a little bit of reflection magic in here because it has to fill the to-do bean somehow. But you can actually do this differently by actually calling the constructor, but it was a little bit longer. It didn't really fit on the slide, so I decided to take a shortcut. Sorry about that. But still, I think this piece of magic, while unfortunate, is defensible. So how about transactions? Normally, you would put an at transaction annotation on a method, and then if you had a problem somewhere, it would be quite hard to trace down all of the methods with the annotation and what is part of the transaction and what isn't. And here it's really clear, everything within this lambda is part of the transaction, period. Super simple. So the pros and the cons. One of the cons is you have to write the SQL manually. That's, well, not everybody likes that. There's still some reflection magic going on, as I mentioned, although you can do without. And there is some duplication between code and SQL because you have to match the names of the SQL identifiers to your bean identifiers, your field identifiers. So there's a little bit of extra duplication there. But the pros are that you can actually write your SQL directly. You know, if you have a problem with performance, and basically every program that uses a database with Hibernate that isn't a toy program has some point where they actually do need to fall back to SQL or some other query language. Here, at least, everything is uniform and presented the same way. Again, you have a clean separation of concerns, I think, and the most important one is that your domain classes are now immutable, which is what you really want, right? This also means that you don't have to watch out that your domain classes with all of their Hibernate enhancements don't filter down and trickle down in your code base. That's not a problem anymore. You don't have to copy them over to some other DTO object or whatever. It's really simple. Okay, the big one, dependency injection. Most people in this room will probably be familiar with Spring or Juice to use as their dependency injection frameworks. There are others as well, but I chose to take a deeper dive into these ones. So with Spring, what does it look like? Well, if you want a thing to be injected, you have to make a field and put the auto-wired annotation on it, and then somewhere else in your code base, you have to have a field or a method annotated with bean, and then those two are matched. And actually, instead of a field, it's probably better to use a constructor instead, and if you do, then Spring will be smart and you don't need the annotation, so you know there's a little bit of profit over here. But you still need the bean. But the main problem, I think, with this is that there are no architectural boundaries. And what I mean by that is I can define my bean in a class. I've called it here, I have something. But nothing is stopping me from defining it in a class called main, or employee DAO, or util, or whatever. I can put it anywhere. And you know, we really need some boundaries here, because if you do that, how are you going to find the bean that you are looking for that is injected somewhere else in your code base? Or even worse, how are you going to find that you forgot to define a bean, because in what class could it be? So let's look at some concrete examples. For example, if I have no match, if I forgot to put the bean annotation in front of the bean, what will happen? Well, if you start the application, you have to first start up the Spring container, you will get this stack trace. And again, as before, over here is the first occurrence of the code that I wrote myself. All of the rest is Spring and Java and whatever. It's useless, basically. But if you look even more closely, you see that this is the main method of the application, where you have the Spring Boot runner thingy. So this is not a place where the problem occurs. So where do I look then? Well, actually, I should probably have read the message of the exception. However, I'm walking back to my laptop now. I have to scroll quite far to the right in order to read everything. That's not very convenient. What happens if I have two matches for the same object? Well, it looks like this. I have two @bean annotations on fields with the correct type. Well, what happens then is I get this message. And as you can see, this is not a stack trace. This is actually something that is written to the log. I do have to admit that it is a lot nicer to read than the previous one. But the fun thing, if you write things to logs, you can disable them, and nobody will ever see it. So this is a fun trick to play on your coworkers when you go to work next week. Good luck finding the problem now. Cyclic dependencies are a similar problem. So what happens is that I have two bean methods, and each one requires an instance of the other one. So that's a pretty easy cycle to make. And what happens is that you get this message. It even has some ASCII art, which is cool, I guess. It's still sent to the logger, so you can still disable it. That's juice. That was Spring. So let's look at juice now. It looks very similar to the Spring one, except instead of auto-wired, you use @inject. And instead of bean annotations, you use a bind method inside of a module class. And this bind method is only available to classes that extend the juice module type. So this is actually nice because that solves the issue of the boundaries, because now you know that you have to look inside of an object that inherits from this type. That makes the search a little bit easier. So let's go through the same exercise as before. If I have no match, what would it look like? Well, I have forgotten here to add my bind method. And when I start the program, I get a very nice stack trace with a very nice message. It's very readable, so points to Google for implementing this. You know, new lines are also around for many years. You can use them. So it's still at runtime, but at least it's readable now. If I make a mistake by having two matches, I bind the something class twice. In that case, I again get an error message in a stack trace, so I cannot disable the logger. The application will crash and it will show me the stack trace. And again, it's pretty readable. How about cyclic dependencies? Well, I think they are possible with juice, but I wasn't able to get it done. So if anybody knows how to do it, please come talk to me afterwards. I would like to know for the next time I give this presentation. I wasn't able to get it done. So at least Jews have made this thing that we don't want to occur in practice difficult to achieve, whereas in Spring it is really, really easy. So again, a little bit better. What would this look like in parallel Java then? Well, we do dependency injection manually. This means that I have a class that requires some object, and I have a main method where I define an instance of this object and pass it to the class. That's it. It's all in the main method, so again, pretty easy to find where you defined your dependencies. So what happens if I have no matches? Well, if I comment out that one line where I define the object that needs to go into the class, well, then the compiler says, hey, dude, you have to define an object because otherwise I can't compile this shit, you know? Pretty obvious. And you get your error message at compile time, which is a lot faster than at runtime, especially if you're using Spring and you have to start up your Spring container. They claim it's fast, but it's not. What if I have two matches? Well, it's also pretty easy. I have two variables of my type something, and I want to pass one of them into the I need something class. I have to choose one, right? I cannot put them in both. This makes no sense at all to put in two of them in the same parameter slot. The compiler simply won't let you. What about cyclic dependencies then? Well, I can define two objects that require an instance of the other one to run. But if I want to instantiate them, well, I have to do one of them first to give it to the other one. But I cannot create the first one. So what if I swap them around? Well, same problem. Again, the compiler won't let me, and you will know immediately what's going on. In other words, illegal states, much like this slide, are unrepresentable. And this is a trait of software, of code, that you want. This helps you a lot. If you cannot express an error, you cannot make the error, right? So pros and cons. Well, the con is that you will have some boilerplate because you have to do all the new, you have to call new all the time somewhere. You have to write that out yourself. And you have one very dirty class because you're calling new in it all the time, and you know we shouldn't probably call new all the time. But in this one class, well, you have to. I actually asked Uncle Bob on Twitter if this is okay, and he said yes. So I guess that's okay. So what are the pros over Spring and Juice both? Well, as I said, illegal states are unrepresentable, and you will get all of your problems at compile time. So that's a really quick feedback loop. You cannot go quicker than this. And as you may have noticed, Juice does it a little bit better than Spring. So there are some advantages that this method has over Spring, but not Juice. Namely, the clear architectural boundaries that I talked about before, and it boots much faster. So about this boilerplate thing that I list as a con, again, you can also see it as a pro, because it makes your code really explicit. It is easy to find things, you know where they are, and they are all in the same place, namely the main method. It's very easy to find where you're wiring your stuff and where everything comes from. This helps a lot when you are discovering a new project, because you can easily find where stuff is coming from. And it helps when things get complicated, because it's easy to find where stuff is coming from. So that's nice, right? Of course, these are not the only things that we use annotations for these days. I'm not going to go deeply into each of them, but I'm just going to show them. For example, JSON and XML serialization and deserialization is used. Frameworks that do this often use annotations where they could easily do without, in my opinion. Same with reading properties from properties files. Why do you need annotations for this? I still don't get it. And for code generation, I know there's a Lombok talk going on in the other room. I actually know the guys who made it, so if they're watching this later on YouTube, I'm sorry, I'm not trying to bash your stuff, but I don't like it. And auto-value is a competitor to Lombok because I felt I had to include at least 2 bullets on this slide. So are all annotations bad then? Well, actually, maybe not. For example, static analysis annotations, I kind of like them because they do what annotations were supposed to do. meaning add metadata to your code. Static analysis tools can read these and then do something useful with it. But if you remove them from your code, the code doesn't change. You know, the runtime behavior of the code is the same. But it helps catch bugs, so you know it's helpful. Same with other metadata annotations. It's sometimes very useful to know if you want to deprecate something, if you don't want something to be used anymore, or if you want to suppress a warning that the compiler generates. And then it's also useful to add in a little string explaining why you are doing this. And this one really should have been built into the language in the first place, right? It has been in Scala and Kotlin and many other languages, and I think it should have been in Java as well. So in conclusion, when do I like annotations? Well, they have to do two things. First of all, they have to do something useful. And second of all, there shouldn't be any reasonable way in doing it differently. And there's not a lot of annotations that can follow the second requirement. So, about parallel Java then. All of these examples that I've just shown you kind of look hypothetical, but I can assure you that they're not. All of this is real code that I wrote a few months ago. Maybe you are familiar with the todobackend.com project. It defines a little API to write a to-do application. And it has a bunch of tests that test this API. So you can write your own application, deploy it to Heroku, and ask this website to run the tests on it. And if the tests pass, then your application is compliant. So this seemed like a small-ish program to make my point here. So I wrote it, and it's fully compliant, my application. So let's show you some more of that code. First of all, this is my pom.yaml, because in my parallel universe, I try to use XML as little as possible. And you can actually write your POM in YAML, so it's a lot more compact. As you can see, it's all written in Java 11. It's actually completely modularized, the application. And I have a little check style test in there as well. Unfortunately, I did have to use XML to configure that. What this thing does is it looks at all the @ signs in my code, and when it finds one, it throws an error. And then it says, annotations are not allowed. So that also means I cannot put any email addresses in comments or anything, but you shouldn't be doing that anyway. But this helps keep me honest, right? No annotations in my code whatsoever. My unit tests are written in the way I described earlier. I'm using arc_unit to even test some of the architectural boundaries I was talking about. This is an example of that. I can run my web server in the way that I described with the get methods. There's also a post for if you want to have a post method somewhere. And talking about the cross-cutting concerns, todobackend.com requires proper handling of cores. So I have also included some code to make that happen, which has to happen on every endpoint. My database looks pretty much like the example I showed you before. And this is an example of my dependency injection, which is basically a very long list of objects declarations. And I have to say, actually, it reads pretty nice, especially if you can line them up a little bit. This is just plain, simple Java code, no explanation necessary, right? What libraries did I use? Well, obviously, for dependency injection, I didn't need any library. But for the web framework, I used Spark Java. For the database thing, I used JDBI, which are all relatively well-known frameworks. And for the unit tests, I used Picotest. And the thing about Picotest is that it didn't exist when I started this project. So I wrote it myself. which was also pretty easy, by the way. You can, if you use JUnit 5, it has a separation between the platform and your API and your engine. So you can write your own engine on top of the platform. And this is actually quite a fun hobby project to do. All of the code is on GitHub. For people wanting to take pictures, I'm going to repeat these lines later on. So in conclusion, when you are using a library, think about using this library, and do you really need this library, and does it behave in the way that I want? In my case, does it use annotations a lot or not? You have to think about it, not just use them because everybody else is using them. Same goes with your frameworks. Will they infect your architecture like Spring does with your dependency injection, or like Hibernate does with your data objects? Or are there alternatives? And the fun thing is that even Spring is developing in the background somewhere a thing called the Spring Functional Web Framework, which uses endpoint definitions like I showed you before instead of annotations. And finally, think about your languages. So pick a language of the year to learn. Can be anything. You can use Scala, which I used to come to these opinions. But Kotlin will get you there as well, I think. Or just dive into parallel Java immediately. Take the shortcut. I have to say, when I was writing this to-do backend application, it's the most fun I had writing a program that I've had in years, honestly. It was a really fun thing to do. So keep fighting those windmills. Read a good book is also some advice that I want to give you. You can read Don Quixote because it's brilliant, or maybe if you haven't read it yet, The Pragmatic Programmer. And don't forget to rate my talk in the app.